Video problem number 44, mass calculations for reactions. This is going to be very similar to video problem number 43. Just it looks at a couple different things, but it's all the same process. So if you're cool with 43, you might want to put this on super speed or whatever you want to call it, because you're going to see a lot of the same ideas. All right. Determine the mass in grams of carbon dioxide. So I'm looking for the grams needed to completely react with 25 grams of water. So anytime I write a line with a G, I write a line with a moles, and these are back to back. Now, what I want to illustrate in these problems is if I am given a certain amount of reactant, I can calculate exactly how much of that other reactant I need to completely react. Okay, and I'll talk a little more about that when I'm done here. All right, so we have 25 grams of water. We're going to go from grams to moles, moles to moles, and then moles to grams. Okay, so I've got 25 grams of water. First I'm going to do is convert grams to moles. So moles on top, grams on bottom. Water, pretty simple. H2O, you got 2 hydrogens, which is 2.016. You get the 1 oxygen, which is 16, so that's 18.016. So 1 mole for 18.016 grams. Now I'm going to show you if we just keep going. Okay, so I haven't done that yet. So here grams cancel out. Now I have moles of water. I'm going to convert from moles of water to moles of CO2. It just so happens it's a 1-to-1 reaction. For every 6 CO2s, there are 6 waters. So water cancels out. Now I have moles of CO2. All right, and so now I'm going to go from moles of CO2 to grams of CO2. So grams on top, moles on bottom. Moles cancels out, so that's grams of CO2. And we found CO2 last time. It was like, what is it? It's 44.01 grams per 1 mole. Okay, so I'm going to take 25 times 1. Oops, hope my calculator was on. All right, so I'm going to take 25 times 1 times 6 times 44.01. And then I'm going to divide by, parentheses, 18.016 times 6. So I get a value of 61, and I want 2 significant figures here, so that's 61 grams of what? CO2. Okay. Now, what this means, and this is the big important part of this video, what this means is that if I have 25 grams of water, I need 61 grams of CO2. At the very end, there is no water left over, there is no CO2 left over. All of it has been converted to the products. Okay? So that's the big idea here, that this is what we would call the perfect stoichiometric ratio. All right? Let's look at the next one. Ethanol burns in air to produce carbon dioxide and water, as shown below. What volume of ethanol? So this is a little bit different. We're looking for volume of ethanol, which is often abbreviated etol, is needed to react completely with 100 grams of oxygen gas. So we have 100 grams of oxygen gas, right? Anytime I write a line with G, I write a line with the moles. And I'm looking for volume. They give me the density, so I think I'm looking for the grams, which I can then convert to volume. So same idea, grams, moles, 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 grams. Okay? So we have 100 grams of oxygen. How much ethanol do I need to react with all 100 grams of oxygen? Well, let's see. I'm going to convert to moles first. So 1 mole on top, grams on bottom, and that's 32. Okay, because it's O2. Let's do this as one problem again. Now I'm going to go from moles to moles. I'm going to get rid of oxygen. I'm going to pick up ethanol, C2H5OH. So for every 1 ethanol, there are 3 oxygens. And now I'm going to go to mass. So let's see, grams canceled out, oxygen canceled out. So I'm going to put moles on bottom, grams on top. So that is the molar mass of ethanol. So the molar mass of C2H5OH. We got 2 carbons, which is going to be 24.02. 5 hydrogens, which is what? 1.04. Is that right? It's 1.008 times 5. I can't think. To the calculator. Yeah, 5.04, not even close. Dope. All right, 5.04. And then what else do I got? I got another oxygen, which is 16. We got another hydrogen, which is 1.008. So that's 5.04 plus 16 plus 1.008 plus 24.02, 46.068. Let me just add that up again, make sure I got that right. So get a value, yeah, 46.068. So that's the molar mass, right? That's how many grams per mole, right? All right, so let's see, 100 divided by 32 equals, divided by 3 equals times 46.068. So I get a value of, let's see, my number is 47.99, and that's grams. And I'm going to keep that because I'm not done yet. All right, and then we'll talk about the significant figures here in a second. So 47.99 grams, and then I have density. Density is equal to mass over volume. I'm looking for volume. So volume is equal to mass over density. That's just algebraically solved for it. So my mass is 47.99, and then I have the actual mass in my calculator still. And the density is 0.789. That's grams per milliliter. So I'm going to end up with volume here. Okay. So let's take that number that's in my calculator, divide by 0.789, and I get a value of 60.8. Well, let's talk about sig figs, and that would be milliliters. Now, 100, there's only one significant figure there. So my answer can only have one significant figure. So my answer becomes 60. So there's one significant figure. But again, you know, that's exactly how much ethanol I need to react with 100% of this oxygen.